Welcome, everybody. My name is Niels Basjes. I'm one of the lead architects at bol.com, and I'm going to talk about a real use case, about real problems for which we've found a solution. And I'm going to talk about the choices we made, the hurdles we took, and why we think this is a very suitable way of solving the problem we had. A bit of an overview, I'm going to talk a bit about bol.com because outside of the Netherlands, I expect nobody to ever heard of us. We're talking about streaming systems in general and the example use case in specific, but only at a high level. And the key problem is getting the message across. A streaming system has some kind of message that needs to be passed over the stream to the other end. So, a bit of background about me. I have a Master of Science in both computer science and business. I've held various software development, research, and architecture roles. And I'm a heavy contributor to many of the Apache big data tools. And I'm a committer and PMC for Apache Avro, serialization system. So, bol.com. We're an online retailer. For people outside of the Netherlands, we're something like Amazon. We're a platform that sells stuff and that allows other people to sell their stuff. To give you a sense of scale, we have a current catalog of over 60 million products, of which over 18 million are currently available. We are in the millions of visitors and visits per month. The number of pages we serve on a yearly basis exceeds the 6 billion nowadays. And as you can understand, the number of items we ship just in the peak season also exceeds the tens of millions. One of the big data things we do on our website is personalization. When I'm recognized on the site, I'm personally targeted with things like services, some overall campaigns, of course, but also campaigns for products and product groups that are tailored to what I have done in the past. Further down the page, it gets more specific. I actually looked at that product and I got additional recommendations on that. The main problem with these solutions is that they have been built over the last 10 years, and is that they're all based on batch processing. Batch processing once every 24 hours. And as you can understand, the value of data decays rapidly with time. So you want to have a solution that operates in the low minutes, even in the low seconds range, from something happens and processing it and responding to it. And as you can understand, that is what stream processing is all about. So several years ago, I started a project which we call Measuring 2.0, which is all about creating the best possible data stream of what happens in the website. If you want to have more details about this project, I gave a presentation at Berlin Buzzwords a few years ago, which is available on YouTube. At a high level, what happens is that in our web shop, the HTML page is rendered, it's put together, and what is actually put in that page is put into Kafka using messages. Then the HTML is sent to the browser, where we register the parts that are actually on the screen. And those are sent back via an endpoint, also into Kafka. After that, we have a component that does some enriching and also takes care of some of the GDPR stuff. And that goes out both into Kafka and into files. And as I mentioned, this is very personal identifiable. So we use this for fraud prevention. But after anonymization, we can use it for all kinds of analytics tasks, similar to what I just shown you. The current volume of this, and that is off-season, is somewhere in the order of magnitude of 800 million messages per day, which are approximately 2 kilobytes each. So we are looking at 1.5 terabytes of day, 1.5 terabytes of data per day. After this, we have applications. So the data is being put into Kafka for usage. And then we have things like the personalization, search suggestions, recommendations, and fraud preventions that are from there and then on capable of using it. And in the future, we'll expect that more systems in our landscape will operate in roughly the same way. Streaming interfaces, requirements towards the low latency, and higher volumes as the company grows. Now, the key question that is very generic to all these use cases is, how do you build such a streaming interface? Looking from a high level at the technology, you have a data producing system, the streaming interface, and multiple data consumers. And all of the technology I've seen requires you to provide the payload as a byte array, just a binary format. If you look at the Kafka API for the producer, you'll see that they have something called a key and a value serializer, just a class that converts the instance into a set of bytes. And then you have an instance that allows you to create the messages. Google has PubSub, and the API is similar. It requires to provide bytes. Now, when thinking about how to put our records onto the wire, transforming our information into bytes, we have a shopping list of requirements. And the first one is obvious. We need something to turn our records into bytes. Now, in the examples, you saw that it's a string. You turn a string into UTF-8 bytes. That never happens. In all the examples, that's what they show. In real life, that never happens. It's always a record, usually multi-level deep. So why don't we pick the usual suspect? Why don't we pick just JSON as the way of structuring our data? Okay, but you have to think about the escaping. Oh, let's pick the other favorite, XML. Same problem, just different escaping. CSV? I'm going to give you an example that I picked up in production. We have a measuring system also from Omniture, which is JavaScript-based, where we send stuff over JavaScript to their systems and we get data back. And at some point, one of the data sets failed. Turned out that this is a tab-separated line, 635 columns, which is like, okay, it's a lot, but that's the way it works. One of those is the product list, which is a comma-separated list of products. A product is a semicolon-separated list of fields, which is a pipe-separated list of key-value things. And in case the key is EVAR8, then it's an underscore-separated thing of the product number and the title. I built an Antler parser to figure this out. And as an example, this is what it looks like. This is just one of those 600 columns. There is, however, a snag here. I simplified the example because that product number is not that title. It's this title. Somebody is picking up the trick. Somebody forgot the escaping. Hence, the parsing failed. So, putting a string into a byte array, JSON, XML, you all assumed ASCII, didn't you? But in reality, you may have been using this actual version of ASCII, with the box drawing. Old people like me remember that. But there's also this one. And these are the differences. It's the other ASCII. Which did you actually use? This is a real big problem in those text formats. People think text formats are easy. They are not. And if you really want to go deep into understanding this, read this blog post. It's like 15 years old by now. It is so true. and it's still a mess. So as a general advice, we use binary formats, because there is code that defines the format. You don't get to choose, which is a good thing. So serializing records, making that easy and reliable is one of our lists. But as you can understand, we also need something like types. Is it a string, or is it an integer, or a floating point, or some kind of collection, or something like that? So we need that. And we would also like something that exposes that in an easy way in our API for our developers. But if we define a schema, you have things like names. You want to name the variables. Is this the street or the city or whatever? Some things are mandatory, some are optional. And if they're optional, maybe you have a default value. Maybe you have some nesting. If you want to do that in CSV, you have to build that in your software. So the schema is in your code, which is hard to transfer to somebody else who needs the data. JSON, same thing. There are developments on the JSON end, but it's still draft, it's beta, and nobody supports it. XML is slightly better. There you have a schema definition. Yeah, we love those. Protobuf is a way better because it has a very readable format for schemas. It's a lot better. And Protobuf also gives you generated code. This is a C++ example that yields it workable to work with these structures. Apache Avro, for which I'm one of the committers, has similar systems. Traditionally, it was created to have a JSON schema, which is like, not that nice. But now they have, since many years already, there is also an IDL schema type, which is what I use most of the time. This is very easy to understand. And also because you can have default values. And the bottom one, the company, is the way you write down that it's optional. This also yields very usable API. Even to the point where the Java doc of the methods includes the comments that you put in the schema, so they're copied along. So with the schema, you can document what it actually means, and that's carried on to everybody who uses it. The Measuring 2.0 project, this is a fragment of the schema. And here you see, for example, that we have import statements to keep it nicely separate and readable, and so it doesn't get too messy. So as you understand, we need something to define and use the record in a much easier way. And then the business comes along, because they need something new. A new insight, a new wish, a new business model, a new feature. So in those records, you will get new fields, new default values. Some fields go away. Stuff changes. So you need a way of easily transferring those schemas also to the consumers. How do you get the new schema? How do you know what the new schema is? In our solution, and listening to the conference, in a lot of solutions, people use Kafka. Now, Kafka is great, and it has one very important feature. It persists the messages for a while. In our case, we keep them for 4 weeks. And if you change the producing system a few times, that it produces newer versions of the schema, you will see that the topic, at some point in time, will have multiple versions. But even if you don't use Kafka, even if you have just a single, if you have a normal queuing mechanism, you still have the same problem. Because if you do a rolling upgrade of the producing system, during the rolling, the new nodes will start producing V2 of the schema, and the not yet upgraded nodes will still produce V1. So you will have a queue with mixed versions during the upgrade. Consumers, you have a similar problem. You're not looking at one consumer, no, you're looking at a multitude of consumers that all need the data. It is impossible to instantaneously switch them. So you need a way of handling that. So in general, what we do is that if we have chosen to put the schema in a separate jar file for easy distribution, also with the generation of the code. But in general, you need something that allows two-way compatibility. If you have version 1 of the schema and you now get a version 2 record, you should be able to read it and map it, and two-way. Now, looking at the systems that are remaining out of our long list, Protobuf does tagging. You see a number here, and that number directly maps into the binary form of the record. So, because they are tagged with a number, the evolution is based on a number, and if you want to do schema evolution, being able to migrate to newer versions, you can do that, but it's hard. And it is very prone to going wrong. So I don't like it. In Avro, the schemas are based on the name. The schema evolution is based on the name. And that is because the reading system needs to have the full schema of the data that is coming in. So you can add new fields anywhere. I can simply add a new field here between the name and the city, and it will just work. So making this two-way compatible for doing rolling upgrades and storing data in Kafka, it's pretty easy to do, as long as you adhere to some rules. So you can understand by now that we are using Apache Avro. Now, the rules for allowing schema evolution are very simple. If you have a field that is mandatory and will never go away, you can just say, hey, I have a string with ID or something. If it's an optional, but you require the developer to always explicitly specify it, you can do it like this. This rarely happens. It's only the really core fields like an ID and a name and things like that. For all the other fields, you have to specify a default. And if it's an optional, you can define the default as the string or as the null, but you have to define a default. Otherwise, reading it, expecting a field, the system won't know what to fill in the blank, and it will fail. There's one catch, however, and that's enums. Enumerations, if you ever change an enum, it is not evolvable. So if you can avoid them, may sound silly, but using a string instead of an enum is better in these kinds of scenarios. Now, in order to support this use case, a few years ago, I built in Apache Avro a new format called the message format. And it needs a registry that maps the fingerprint of the schema, which is essentially a hash, to the JSON version of the schema. Now, this format is very simple. It's essentially a small header, the fingerprint, which is a 64-bit number, and then the binary version of the record. So the binary that goes into Kafka in our case is slightly bigger because it contains the schema ID, but that's it. And you need a schema registry. Putting the new JSON version of the schema into the registry is something we put in our CI build. So when we tag a new version of the schema, it's automatically put in there. And then the jar file is loaded into the producing application, it starts producing, but by then the schema is already in there. And what we also have is unit tests that explicitly check against the recent historical versions of the schema, are you two-way compatible? And it fails if it isn't. Now, producing this kind of data into Kafka from a system like Flink is now very easy, Because in the generated code from Avro, because you generate the IDL into Java classes, there's now, this person is a generated class, and there is a 2-byte buffer method that does this transformation. So transforming the instance into the serialized form suitable for this kind of evolution, it's that. And if you have this serializer, you can then use the Flink Kafka producer and just give it like that. So putting it in the stream in this way is very simple. Getting it out for the stream requires one extra step. Because in case it doesn't already have the schema available, it needs a way to retrieve it from the schema registry. So that's the only extra code you need. The decoding itself, again, is very simple. And then you use this deserializer in the source. So doing this in production really works. And we even have some additional things. So like I said, it really works great for doing this streaming kind of thing, extending the model, measuring more things on the website without breaking downstream applications actually works in practice. One of the nice things is that we don't need to upgrade all the consumers. A consumer running on version 1, and that's all the fields they really need, it's fine. Because the schema evolution built into the system automatically takes care of that. In fact, some applications have used the schema evolution to reduce the load on their system. They simply copied the full schema, commented out all the things they didn't need, generated the Java code from that, and they had this mini schema that by the schema evolution is automatically mapped correctly. And because not everything is extracted, they had a lot lower load on their garbage collection. And although completely off topic, I have used this exact same serialization of a record into bytes and back again to store records into HBase. I had a lot of data coming in. I didn't want to think about problems of serializing and deserializing, so I made an IDL, generated the code, and just shoved the bytes into a single column in HBase. And it made work very easy. And if I decided to have new records at some point and then store them in HBase again, there was no need to update the older records, because reading them would simply work. This is my story. This is how we did it in practice, how we made sure that applications can evolve as painless as possible. Thank you. Yes, there's a mic. It's stuck. Yeah.
It's working. Okay. Okay, it's a strange feeling, but okay. I've worked with Avro and Kafka, and it suits a lot of problem. There is one commentary maybe on the optional value, because everybody say if you want an optional value, you just put null all the value. But there is a slight difference between nullable and optional value. Maybe, and that was my case in my use case, you have to differentiate the fact that the people want to send the value and the fact that the value is actually null. So sometimes, I don't know if you get it, you have to, the null comma string, it's not a true optional string as it would be in a Java 8 code, for example. And it's a problem which is not so easy to solve. The second part for Avro is when you do nesting and you have sub-object. Well, actually, you have to do a proper Avro schema, which is self-defined. So you cannot reuse, well, I don't know how to correctly reuse nested sub-objects that maybe are usable for a lot of people, and I truly don't want them to be rewritten for every project that will use this subtyped object. So do you have like a good solution for this kind of problem?
For the nesting, the first thing I'm thinking about is that in the IDL you can use includes.
Yeah.
Maybe you can put that in a separate include file so that it can be reused. Because the package name would be the same, so I would expect that to work.
Yeah. Well, we are using also the Kafka registry, and they do some checking on the schema.
Okay.
So you have the schema has to be fully defined. So the only solution we have seen is to create actually two schema, one which is self-contained with every definition,
Okay.
and one using some imports. Then we can use the imports for code, and we can use the big file for the schema definition. Do you think it's a good idea, or is it kind of stupid?
Let's take this offline. I think that for the rest of the group, this goes too deep. So let's talk after the presentation, okay?
Okay, sure.
Yeah? Any other questions? Yes?
Do you also use it with NiFi?
I've heard that our IT ops people use a bit of NiFi, but I haven't used it. No, the streaming applications we built are mainly running Flink. Yes? We simply put the messages, the schemas into a separate Kafka topic. We kept it really simple because the systems already have a connection to Kafka, and a Kafka topic with like, I don't know, 20, 30 messages is really easy, and you know, because every instance only does one query per unknown schema, it's not a problem. Yes, the schema is then cached in memory. The schema is in the registry as the JSON format, and that is parsed into a schema instance, and that is cached. So the performance difference is negligible. Yeah. Any other questions? Yes.
You were talking in the deserialization part on when you don't have the correct version, you have to go and get it somewhere.
Yes.
Could you expand on the subject? Because
Okay. What?
schema has to be bundled in the app.
Okay. What happens is that if you generate the Java code from the schema, that Java code has the schema ID built in, has that schema built in. So if a message arrives with that exact schema ID, it immediately deserializes and it will just work. If you get a schema ID of either an older or a newer version, it is not part of the Java code, and then it has to go somewhere to retrieve it. And that is the part that I mentioned. Then that is where, in our code, we go to Kafka and retrieve it. But as far as I know, Confluent also has a schema registry. But for all I care, you put it in a property file, or you put it in a Redis database, or it really doesn't matter. The only thing is that you have a 64-bit number and a string. And that's it. It's a key value. And then when it's retrieved, it's parsed, instantiated, and like I mentioned, it's cached. And then what happens internally in Avro is that it has a reader and a writer schema. So it has both schemas of the actual record and what is expected. And at that point, the schema evolution is done. Yes? Okay. Yes? Okay. Thank you.